Alright, on to the last page where we start writing some functions. This one we're going to start with is a parabola. And what you first want to do is, like I just did, is identify the parent function. And then you want to identify the most important point. So in this case it's the vertex, which looks like it's gone right 1, down 3. And then always double check to make sure it goes up 1 over 1. In this case it does, which means there's no stretch. So I'm going to write x minus 1 squared and then minus 3 because it went down 3 and right 1. Right, the second one, you should be writing an absolute value function because it's a V shape. But this one, notice, hasn't shifted right or left, so I'm just going to have the absolute value of x. But it does have a stretch. It's gone up 1 and over 1, 2, 3. So the vertical part of it is 1. The horizontal part is 3. So our function is x over 3. And make sure your bars go all the way around that. Right, the next one, notice it's not a parabola. It's actually a semicircle or a semi-ellipse, because it has endpoints. It has these two little endpoints. Notice the center still at 0, 0. So remember the parent function for a half circle is similar to the swimmer's arm, but it's 1 minus x squared. Okay. So outside we're going to put our vertical radius. Inside with the x we're going to put our horizontal radius. So the vertical radius looks like it's 2. So I'm going to do 2, and I want it to be positive because I have the top half of the circle. My horizontal radius is 3, so it's x over 3. Make sure that's inside the parentheses and under the square root. Right, the next one you should be thinking is the swimmer's arm, which is a square root function. It's got a reflection. Now it's a reflection over the y-axis, which means the negative goes inside. And it hasn't shifted to the right at all, so I don't need to include anything with x, but it has gone up 1. So that's my final function. The last one is going to be a squared function. Okay, it looks like it hasn't gone right or left, so I don't need anything on the inside. It's shifted up 2. And also always double check, does it go down 1 over 1? And this one doesn't. It goes down 2 over 1. So I need a 2 out, and also notice it is flipped or reflected over the x-axis, so I need a negative 2 out front. This one's slightly different. I want you to look at the top half first, then look at the bottom half as a separate function. So I split it into 2 really. The top half, if we just focus on that, that's a swimmer's arm. So that means I'm going to have the square root of, and it hasn't gone up at all, but it's gone to the left 1, so it's going to be square root of x plus 1 on the inside. And it hasn't reflected yet because it's on top. But then this one is a reflection, the blue one. So that's why I need the negative and the positive portion. So I really have a plus to get the top and a minus to get the bottom. Right, on to the last 6. Oops, that's a repeat. Right, so I look at this one and it's a half circle, but it's a bottom. So I know I'm going to need negative square root of 1 minus something squared. Excuse me, what are you doing? Get off the table, Callie. Get down. Sorry, my dog is climbing on the table. All right, now I want to find the center, which it looks like it's gone to the left 1, but it hasn't gone up or down. So I'm going to put x plus 1. All right. The vertical radius is 1, so I don't need anything outside here. But the horizontal radius is 2, so I'm going to put x plus 1 over 2, and that has to be in the square. Right. This next one you should be thinking is a V shape, so I need the absolute value bars. It's reflected, so I need a negative. Check the stretching, down 1 over 1, we're good. It's gone to the right 2, so I need negative x minus 2. Right, this one, notice it has endpoints, which means it's a half circle or ellipse in this case. Find the center, and it looks like it's gone down 1. So remember, the parent function for every semicircle is 1 minus something squared. Right? And then remember, it's gone down 1, so that's going to go on the outside. The vertical radius is 4. The horizontal radius is 1, so I actually don't need anything with the x on the inside. Outside I need a 4, and I have the positive part, so I just need the positive portion. This one is an S shape, so it's a cubic, and it's always helpful to plot that point. It's gone to the left 2, and it's also going backwards. A normal cubic looks like this. So that means I need a negative. It's gone to the left 2, so I need x plus 2 cubed, and it hasn't gone up or down. And up 1 over 1 is my next point, so it doesn't have a stretch. For a rational, it's always helpful to find your asymptote. So there's one, and the next one is this one, up 1. So it hasn't gone right or left because my vertical asymptote is still on the y-axis, but it has gone up 1. So I just need 1 over x because it hasn't gone right or left, and the 1 goes on the outside because it's shifted up 1. And remember, we don't worry about stretches for rationals. And the very last one is a cubic. It's gone right 2 down 1. So I'm going to get x minus 2 cubed minus 1. It's not reflected. And again, I go up 1 over 1 to get to the next point and down 1 over 1, so it does not have a stretch. So that's my final answer. Hope this helps and have a wonderful night.